Alright, if I wasn't a mad scientist before, I am now. Chop this guy up. Look at this thing, it freaking failed. That's like that out of the box. We didn't have enough adhesion, I guess, to the platform, whatever. I tried printing at a much finer resolution here, and I don't think I care for it. I don't think it does any good. Fail. I don't think my printer likes to bridge with that fine of filament. When you do engineer something just right, though, man, we're hopefully going to have a very well sealed device. After we fix the printer, real quick, something for the LED photon array. It slides right there in that slot ever so nice, all the way down. So we'll be able to carve out that outer tube so we can get lights on both sides of this thing. We're gonna cut this outer electrode like this to allow the light into the cell on both sides. I decided to just say forget the red LEDs like I had previously wired up here. Given UV is going to be a more powerful light, and so we're just going to go with these. These are in the 400 nanometer wavelength, so UVC, if I'm not mistaken. I'd like to get some UVB to see how they operate, but we'll test these first. I did come across a video, maybe I'll slice it in right here, where Stan talks about LEDs being used because they are basically laser energy. It's light emitting their photons, so LEDs will work.
In order to do this, we now develop what we call a hydrogen gun technology, or a gas resonant cavity. We're now introducing laser energy into the system. We do not need high energy lasers to accomplish the task. We are using solid state lasers. Those are actually LEDs. If anyone knows about LEDs, do they not discrete in a discrete amount of light frequency? Are they not a solid state laser? And as a result, if you put them together, you can come up with the laser intensity and pulse them in such a way that you're now co-equaling or maximizing the absorption of photon energy into the process. Go ahead, as we're exposing the high voltage. To do this, we now develop the electron extraction circuit. This is where we're taking the liberated electrons and we're now taking it out of the resonant cavity. If I set up an alternate pulse here, for an example, and these negative charge electrons now, if I would apply a positive voltage field potential here, would not the negative charge electrons go along this wire interact with the filament of this light bulb to produce heat energy from light energy? Am I defying any laws of physics? No. If I apply a high voltage pulse to it, those liberated electrons can be taken right out of the resonant cavity. So as these negative charge electrons are going down the wire, have I not complied with the definition of producing electricity? Is not electricity defined as moving electrons down a wire? So the byproduct of the hydrogen fracturing technology to prevent the formation of water molecule from forming during thermal gas ignition, guess what? Is electricity. Now isn't that amazing? It becomes a self-sustained oscillation system.
This is Stan's Revenge.